So welcome back to another seminar here for Silicon Dojo. So basically what I've done is I've created a hands-on technology education class thing here in Asheville, North Carolina. One of the things that I do is every week we do a seminar on different subjects, and so what I've decided to do is after I've done the seminar for the live audience, more or less the day after, I will record the exact same seminar I did the night before, but basically it's kind of like a director's cut commentary, all of the issues that I ran into, any of the problems that I found with doing the seminar, I will talk about it doing these particular videos. So today's class, what we're going to be going over today is computer speech recognition using Azure Cognitive Services, and I think that this is absolutely awesome. Look at that. That is a hell of a thing. So with, I don't know, this is something like 48 lines of code. I literally have my little MacBook Pro here. What this is doing is this is listening to me. It's sending my speech up onto the Azure Cloud Services, and the Azure Cloud Services is responding with JSON. So JSON is basically a JavaScript language form of being able to format data. So that gets sent back, and then that can be printed out on the screen, or any other number of things can happen with the text. Look at that. That's just a hell of a thing. So the director's cut of this. One warning that I will give you, a warning, is if you are going to do live demonstrations for a class like this or any other classes, just realize the demonstrations may become a hell of a lot more complicated for you to create than you initially realize, right? So one of the things that I came to is right now I'm actually using a Raspberry Pi in order to do some functionality, be able to do things like turn on a fan and all that. My hope, my original idea was that I was going to install the Azure SDK, the voice SDK onto the Raspberry Pi. After a day, I found out that I could not do it. So I spent a day troubleshooting my Raspberry Pi trying to get Azure Speech Services to work properly on it. And it wasn't until you look all the way through the documentation, all the way down at the end. Here's the thing, Azure Speech Services work with Python. Azure Speech Services work on Linux. Azure Speech Services work on Python, on Linux, on x64 processors. They don't work on ARM processors. Yeah, I spent a little bit of time troubleshooting that. I kept getting all these weird errors basically saying like you cannot write to this particular part of the storage or whatever. Can't write to the files. And I thought there was a weird permission issue. I thought there was something I didn't understand about the Raspberry Pi OS, and that I had screwed up my permissions to wherever Pip was trying to install the module for the Azure SDK. It wasn't until like a day. I did all kinds of Google searching, I did all kinds of troubleshooting, couldn't figure out, I got errors. You know what none of the errors said? None of the errors said this doesn't work on the Raspberry Pi. All kinds of other errors. Anyways, after about a day of troubleshooting, after doing a lot of research, finally, if you go all the way down to the end of the requirements or whatever for the SDK, there's this thing for different operating systems and different languages, and you gotta do all this, connect the numbers, and yeah, so Python works on x64 Linux systems, not ARM Linux systems. If you want to work on an Arduino, learn C#. So again, it will work on Arduino. It works on Python, it works on Arduino, it works on Linux. Just not Python on Linux on Arduino. If you want to use on Arduino, then you could probably use something like C#. So anyways, one of the warnings that I will make, if you are going to be doing any kind of these types of examples or whatever, is just make sure you give yourself enough time to actually be able to build these projects, because I mean building projects for classes, for demonstrations can be at least as complicated as building things in the real world. The main reason is because they're one-offs, right? The idea when you build things in the real world is that you build it once, it's a pain in the butt to build it the first time, but then the second, third, fourth, fifth, 20th time it becomes very easy. One of the things with doing these classes is I'm always doing this the first time. I never build this for the second time because I'm going off to the next class after this. So anyways, yeah, just one of those troubleshooting things to think about. But look at this. Isn't this cool? All that's coming out. So anyway, so basically what we're going to do today is I am going to show you more or less how this works and why this is really, really, really cool. Now again, one of the other lessons that I learned Director's Cut is I have 3 different systems connected into this monitor. So I have my keynote presentation on this MacBook. I have the MacBook that's actually driving most of the code in here. And then I have my little Raspberry Pi that's actually doing processing and things. So these are all connected into my screen. And so in order to flip through all these different things, I actually have to go to input and flip through. So I think one of the lessons, the takeaways, I would say what I'm going to be doing in the future is I'm going to just get a little desktop HDMI switcher with buttons on it, so I can just click 1, 2, 3, 4, and that's a little bit easier than flipping through with this darn input thing. Again, it's a stupid. Whenever you're going to do anything in life, again, whether you're teaching classes or building infrastructure, so many times the problems you run into are the stupid things, like having to click the input button and flip around and figure out what the hell it is you're trying to say. Anyways, okay, so this is the presentation for Azure Speech. I absolutely love Azure Speech. I love Azure Cognitive Services. Just to be clear, I am so excited about Azure Cognitive Services, I'm going to learn C#. I put that out there on my social media, like, oh, I'm excited to learn C#. And then I just started getting a lot of hate. Geeks are weird. Geeks are very weird what they give you hate about. I can't believe you learn a crappy language like C#. But C# gives you all these really cool fancy things you can do. Anyways, I don't think C# is considered a cool coding language. But here's the funny thing. It solves a lot of problems that I care about. So anyways, so I really love Azure Cognitive Services. I've been playing around with Azure Cognitive Services for about like a month and a half at this point. And I do have to say, as far as Azure Cognitive Services go, it's really, really cool. They are relatively simple to implement. I've done the vision services in the past, doing the voice services now. I've played around with some of the other services. They're relatively easy to implement. They're relatively powerful. And I do have to say, Microsoft, they are not the worst documentation for folks that are the companies that document what the hell you're supposed to do. Microsoft's documentation for Azure Cognitive Services, to be clear, is not great, is not wonderful, is a complete pain to figure out, which is about 2 times better than their competitors. So anyways, I like Azure Cognitive Services. Now I will give you a warning! Oh, warning! Imposter alert! Imposter alert! So I've been hanging out with real coders lately. Real coders! Not like me. Coders. Right? People that actually do Node.js. Yeah, I hang out with Node.js people. Look, I'm not prejudiced. I'm not biased. Deal with people as they are. I'm not going to look down on you for coding in Node.js. It's just going to be a little bit harder. Geeks are weird. Just for any noobs out there, I just do have to say this. It's weird how snide we get about different technologies. You work on that? Anyways, one of the warnings that I'll give you is whenever you're going to be looking at my code, my priority here for Silicon Dojo is basically to explain what these technologies can do, try to implement them into projects that kind of show the power of the technology. That doesn't mean the syntax of my code looks good, nor am I doing it the most efficiently or anything else. Again, remember, I've been in technology since 1996, dealing with US Army systems. I got my MCSE in 2000. My MCSE may literally be older than some of the people watching this video. I'm an old school IT person. Again, duct tape was actually in my toolkit back in the day. And so when I'm showing you a lot of these projects, just do realize I'm trying to show you the power of these technologies, what you can do. You don't necessarily want to copy my syntax. I am just kind of putting that out there. Again, especially as we start talking about more of these subject areas where it does get more into coding. I see it. I mean, that's one of the things. If you don't really want to feel like an imposter in the real world, one of the things is just be honest with your skill level. I am really good with putting weird-ass technology together and making it do something cool. I'm also really good with using duct tape. So, that's just one of the warnings for this. Now, as far as Azure Cognitive Services and why I'm so excited about Azure Cognitive Services, so Azure Cognitive Services are a component of what are called Azure Cloud Functions. So basically what these are compute services that you can access the same way that you would access a normal API. So think about back in the old days, if you're thinking about storage, if you're thinking about email services, any of those kinds of services. Now Azure offers basically what are called cloud functions, which give you compute functionality. So when we talk about compute functionality, we talk about things like being able to encode video files. So instead of having a video encoder installed on your computer, you can actually have Azure just simply encode the video files for you. You can have computer vision. You do not have a local server. Azure does a computer vision for you, sends back the data in what's called a JSON format. Again, computer speech. You don't have a local server dealing with the speech. You send the speech up to Azure Services. They give you back, again, what speech is recognized in that JSON format. So the cognitive services are a component of what are called these Azure functions, something called serverless architecture. What is interesting about Azure Cognitive Services, and what I'm really excited about with Azure Cognitive Services, is Microsoft seems to be saying with Azure Cognitive Services is let's go back and question what we are actually looking for when we are talking about artificial intelligence. So artificial intelligence is one of those big buzzwords. Artificial intelligence, VR, blockchain, right? So a lot of people throw out these words, and then they don't really think about what the definition of the word is. Do we actually want this? Again, when we talk about artificial intelligence, do we actually want real artificial intelligence? Or do we simply want services that we associate with intelligence? Right? When you think about vision services, do I really care if the computer is intelligent to give me those vision services? Or do I just want a response? What's the difference to me as the end user from artificial intelligence to just a really fast database engine? Right? Again, this is actually a question I've been talking to a lot of programmers and a lot of other technology professionals about recently, where our databases have become so powerful, so fast. If you can just put a gazillion queries essentially into a database and it can process those queries just almost instantaneous, is it better just to have a big ass database or to have artificial intelligence? Again, these are things to be thinking about. And so what Microsoft is doing here, which I think is really cool, is basically they're saying, what do we think AI is? What do we think AI is going to offer us? And then let's offer the result, let's offer the solution, and let's stop worrying so much about whether it's actually AI or not. And so again, when we talk about computer vision, is computer vision AI? I don't know, that's a hell of a question. But if I can have a computer that tells me what the hell it's saying, I don't really care, right? To me, that looks like AI, whether or not it actually is AI. Again, when we have computer speech, is speech recognition AI, or is it simply pattern recognition? That's a great question for the academics. Academics, go grab a couple of beers and argue about whether speech recognition is really AI or just whatever. Right? But what's interesting here is all I care about is that the computer can tell me what it's hearing. That comes back to me in text, and then once it's in text, I can do a lot of amazing things with text. Text is easy to deal with in the computer world. I can input text, I can dynamically create text, I can read from text and look for trigger words and that type of thing. Text is incredibly easy to deal with. So what I want the ability to create code where I can interact with text. Don't really care whether Azure Cognitive Services are really an AI, right? So I think that's one of the interesting things. And again, this is something we need to be thinking about as professionals. Where does the value of what we're thinking about, like the concept, end, and where should we be more focused on what product, what actual solution we're looking for? And so Azure Cognitive Services is a great thing for that. I love Azure Cognitive Services. Again, it's very easy to set up. When I started dealing with voice, I don't know, a month and a half ago or whatever, like just to give you a hint how easy Azure Cognitive Services were, within 1 hour, I went from not having an account to actually being able to modify code and get back results within an hour. I had my account up and running, I configured my Azure services, got my keys and all that kind of stuff. I got the code, and I was modifying the code. in 1 hour. Again, one of the nice values with Azure. One of the things I like about the Microsoft world, and again, I am an old school MCSE, all the way back from 2000, so again, maybe it's my personal bias here. One of the things I do like about the Azure world is that it's built on a standardized type of language. Microsoft has had a type of language for decades at this point. It's one of those, if you understand what Microsoft is trying to do, it's pretty easy to figure out how to accomplish whatever it is that you're trying to accomplish. And so that's, again, that just might be my bias, but it is real. Again, serverless architecture, why this is very powerful again in this whole IoT world, is now you can get compute services, again, the same way you can get an API call. So in the past I've done a class on Twilio where you can send SMS messages or receive SMS messages using an API call, right? That's pretty simple. Okay, you have text data come in, you route it or you parse it or you do something, woo, cool, right? Not that fancy. What's cool about serverless architecture is that this is actually giving you compute resources. Again, if you want to encode video or audio files, that is a compute task. If you want to, basically take speech and turn it into text, that is a compute task. If you want to do machine vision, that is a compute task. What makes serverless architecture so awesome is now those compute tasks are an API call away. You create an account, you get your key, you get a couple of other things in order to do your credentials, and again, within an hour, you're actually sitting there working with a finished, you're working with the infrastructure. Again, I know a lot of people nowadays, again, some of the new folks out there like, I don't trust any system I can't see. Here's one of the things that I'll point out when we talk about serverless architecture is, let's just say you're going to create your own speech, server or whatever. That means you'd have to buy the server, means you'd have to build the server, means you'd have to install the operating system, install the configurations, you'd have to maintain it, patches and antivirus and all that kind of stuff. All of that would have to be done. There's a real cost outlay in order to spin up a server. There's real ongoing maintenance costs, the whole 9 yards. One of the great things with serverless architecture is you just create your account, and then most of them are free. So if you don't use very much of the service, it's absolutely free. And even if you start using a lot of the service, it's still relatively inexpensive. So like with Azure voice, speech to text, it's $1 per hour of speech, not $1 per hour that it's on, $1 per hour of speech recognized. So you can sit there. You know what I'm saying? For $20, for $20 US, you can use a hell of a lot of speech recognition. And then if it works, you keep using it. If it doesn't, you just scrap the project and move on. That is a hell of a lot more cost effective than sitting there and actually spinning up a server and the whole 9 yards. When you deal with serverless architecture, basically what's happening is you're sending the file, you're sending whatever to either what's called a cloud function. So the generic term for serverless architecture is a cloud function. In the Azure world, of course, it's Microsoft. With Microsoft, if there is a generic word for anything, they are going to try to trademark it. So they call them Azure functions. But Azure functions are the same things as cloud functions. Basically, you send the file up, you give the requirements, and then you get back JSON results. Again, serverless architecture is absolutely amazing. When we start looking at what Azure Speech Services have to offer, now again, we talk about Azure Functions. There's over 200 functions that are available for serverless architecture. What we're looking at today is the speech functionality that exists. So we have convert speech to text. So this is something that we're going to be dealing with today. Give your app a voice. So your app can now talk. Translate speech in real time. So again, depending on what you're doing, you could have one person in English basically speaking to somebody that speaks, Lao or something. Again, this is one of the things that becomes very interesting and very powerful. As somebody who's traveled all around the world, India, Thailand, Vietnam, Chile, blah, 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 right? One of the interesting things is that there are so many languages in the world that a lot of times when you have little translation devices or anything else, it's only for a very few specific languages. What becomes very interesting for the hospitality industry is, what if you have an app, let's say you're in a hotel, you have a restaurant or something, and you have an app for all of your employees, and that app can translate for anything, any of God knows how many languages are out there. You can speak into it, it speaks to the person in their language, they speak into it, they speak it into your language. All of a sudden, it becomes very easy to talk with people when you don't share the same language, and you can actually have that real-time speed translation as part of the Azure services. Verify and recognize speakers. I think this is really awesome. And again, this is one of the things that I'm excited about with Azure Cognitive Services, is whenever we think about what technologies that we're going to use, or we think about what companies that we're going to use, one of the important things to think about is the stack. So in the consumer world, it's normally called the ecosystem. In the technology world, it's called the stack. So the stack is all of the technologies that are built basically to support each other for a particular vendor or a particular technology group, right? So when we talk about the stack in the Azure world, right, Azure is owned by Microsoft, and so you have the Active Directory stack, you have the Exchange Server stack, all their communication services, you have their file services, you have a lot of other things that are built into the stack that Microsoft offers. So it becomes really cool here when you have verify and recognize users. Imagine if essentially you can have your users be able to talk to an Active Directory computer, or a computer that's part of an Active Directory infrastructure. Why this becomes very exciting is, imagine you have a calendar system in the Microsoft world, and so you have a CEO. And the CEO, obviously, they block off specific times for when they're doing things. So imagine if you have employees and they can talk to the computer and ask the computer to do things, and then based off of who they are, the computer knows what permissions to give that particular person. So imagine you have somebody in the sales team. So somebody in the sales team, they have this really cool idea. They've got to tell the CEO this really cool idea they have for how to expand business for the company. But they're a salesperson, right? So they should have a little bit of information about the CEO, but maybe not a lot. So the salesperson could say, hey, computer, I would like, is the CEO available at 2 o'clock today for a meeting? And here's the thing, the computer can then identify who is speaking to it, realize that they're a salesperson, realize they can know some information about what the CEO does, but not a lot of information. And so the computer can simply spit back, the CEO has an appointment at 2 o'clock today, but they are available at 4:30 this afternoon. Right, so that is the salesperson being able to communicate with the computer realizing who they are because of security policies, then providing certain information. Whereas, let's say the secretary or the assistant to the CEO is trying to figure out how to schedule a day, and the assistant or the secretary can say, hey computer, is the CEO available for 2 o'clock today? And then, based off of that voice recognition, because it can identify and recognize a speaker, it knows that this is the secretary or the assistant, and so the computer can come back, the CEO is in a meeting with, Billy Bob's, hot dog stands, whatever, in order to try to complete a contract or something like that, right? So basically the computer knows who's talking to it and can give even more information. And could also say with there, this is an incredibly important meeting, so it cannot be rescheduled, or this is not a very important meeting, and so it can be rescheduled. Right? And so all of that can be presented based off of the computer system identifying who is asking the question. Again, this becomes very, very cool when you start thinking about that overall stack. It's not just simply about speech. It's about speech and Active Directory and calendar services and communication services and all kinds of different things. You can activate your assistant or IoT device with a custom keyword. So again, you're used to saying, hey, S-I-R-I. I feel like I have to deal with kids nowadays. S-I-R-I, because I don't want to activate your systems, or hey, A-L-X-E-A or whatever. You can create the same type of thing for your special system, right? So in your corporate environment, you could say, hey computer, or hey robot, or hey dummy. However you want to be passive aggressive. However you want to be passive aggressive towards your systems, that's your business, but it's about. And then add voice commands for hands-free scenarios. Again, I think this is really kind of interesting to be thinking about in the modern world. So imagine you have a mechanic. A mechanic has all kinds of grease and everything. They're sitting there, they realize they need a new carburetor. Imagine them just being able to say, hey computer, I need to order a new carburetor for a 67 Mustang. I don't want the price to be over X amount. And the computer can spit back, okay, this company has a carburetor for this price and they can ship it in this amount of time. Do you want me to purchase this item? Yes, purchase that item. I think that's kind of a hell of an interesting thing. And again, this is where, what I find very interesting about the IoT world is basically this idea of how do we start rethinking how we're interacting with our computers. We've been so used to computers with mice and keyboards and touch screens and all that kind of stuff. It becomes an entirely different world when you start interacting with a computer with things like voice. You can come up with entirely new ways of doing things. I think it's interesting. Now, one of the issues that you're going to run into with the Voice SDK for Software Development Kit for Azure, basically this is just something you install very easily, is it's highly compatible for certain things. It's like when you first look at the requirements for Azure Voice, you're like, wow, it supports all these languages. It's like, yes, it supports all these languages for speech to text. With intent recognition, it only supports those languages. With speaker recognition, it only supports those languages. With something called keywords, it only supports those languages. This is something to be thinking about. Again, a lot of people ask, what language should I learn? What is the best programming language? Remember, the best programming language is whatever the hell works. So, surprise, for Azure Services, C# works for absolutely everything. Again, these other things, you actually have REST. You can actually use REST for a few of these things. You can use Python for many of the things. So, it's one of those, that's something to be thinking about if you're going to be using these services. What language do you need to know? It may be Python may work, REST may work with what you're trying to do. You may need to learn C#, all of that. Then beyond that, which is a real pain in the hoo-haws, as I would say, that is the technical term, is then you have this. So then you have about the Speech SDK, Software Development Kit. So this is basically what you just install onto your computer, on your server, so that it can communicate with the Azure services. And if you scroll all the way down, all the way down, you have Get the Speech SDK. And here is where it shows you different things for different operating systems, right? And so, for the Mac OS, it tells you all the stuff that works. On Linux, and this is where I got mucked up. x86 Ubuntu, x64 ARM32, that is for C++. You have x64 ARM32 ARM64 for Java, x64 ARM32 ARM64 for net core, so that would be C#, and then x64 for Python. And so whenever you see x64, x86, or x64, these are the Intel processor lines. So for Python, it does work on Linux. Or the SDK does work with Python, does work on Linux, as long as you're on an x64 processor. So, be careful with that. Again, with all this stuff, when you start playing with it, just realize if you're having a lot of difficulty trying to implement a solution, it probably means you screwed up on the requirements somewhere. So, again, one of those things just to keep in mind. And then the next thing to be thinking about is something called SSML. It's their language style. So everybody now is coming up with their own cool markup languages, which actually makes a hell of a lot of sense, right? Whenever you're dealing with these services, there needs to be a way to create a language for these services so that you can customize them based off of whatever you're trying to do. I think about this with, TwilML. So I did the class on Twilio and SMS messaging, and there's a markup language for Twilio. It's not proprietary, but it's a custom markup language for Twilio, so that when you're doing things like formatting text messages, that you can actually format them properly, right? You have to tell the computer what the hell it is that you want. Anyways, as far as Azure language services go, they have SSML as Speech Synthesis Markup Language. So basically what this does is it tells the computer how you want the computer to speak to your users, which actually becomes really, really pretty interesting. Oops. Where am I at? So if I go and I click on this, I'm not going to give you a full demonstration of this because there's a lot to it. But basically with this, what you can do is you can do things Like you can change whether it's a boy or it's a girl talking. They have something like 20 different voices. So if you want different voices, so Aria Neural, Jenny Neural, Guy Neural, Francis Neural. So all of these are entirely different voices. So if you want the computer to speak differently to people, you can. Beyond that, you can change like the emotion in the voice. You can change the pitch of the voice. You can change the speed. So something to be thinking about, right? If you have some kind of normal communication system, and then all of a sudden you have an alert, right? To human ears, if people speak faster and higher, that triggers something to know that there is a problem that they should listen to. So something to be thinking about if you're creating a voice interface is when an alert happens, how do you modify the voice communicating the information to also present some type of information to the people, right? Oh, the computer is now speaking faster and higher. That means this is more important. I should pay attention to this. This becomes very interesting when you start thinking about, again, the interfaces in some kind of a speech world. The other thing to be thinking about, again, in the real world, when you have employees, one of the big things when you have employees, especially when you have a lot of employees, right? Employees come with psychological baggage. I'm gonna tell you something shocking. You know how I say bosses are humans, and you should probably treat your boss like a human? Well, for all the bosses out there, I'm gonna tell you something even more remarkable. Your employees are humans too. And they outnumber you. And one of the things is we all have our own psychological baggage, right? When you go to deal with your boss, one of the things that I say is just realize your boss's spouse may have a drug problem. Your boss's spouse may be dying from cancer. Your boss is kids may be having all kinds of issues. So if you storm into your boss and you start demanding things, they may just have bigger issues on their particular mind, and if you don't treat them like human beings, it's probably not going to go very well. One of the things to be thinking about with employees, when you start having the computers actually communicating with them verbally, remember that employees have psychological baggage too, right? They were brought up by mommies and daddies, and oh my golly, I've talked with so many of my viewers. They have so many mommy-daddy issues, right? And so something to be thinking about, right? If a computer has a voice that triggers a response in your employees, that's probably not going to help things, right? If they had an abusive parent and your computer sounds like the abusive parent, and the computer is like, warning, warning, server room is overheating, turn on the air conditioner, right? And this sounds like their abusive parent when they were 6 years old. Yeah, one of the employees is going to be like, damn you! I will not do what you tell me to do. When I was 6 years old, I should have told you to go screw yourselves, and now that I'm 26 years old, I'm not going to take your tyranny anymore. And your server room is melting down. Because, your employees are dealing with psychological issues from their childhood, which is a real thing. I'm laughing because it's real. So one of the things to be thinking about, again, with the whole SSML, basically their speech markup language, is to think about how your computers communicate with your employees. What voices and what way of speaking elicits acceptance and elicits your employees to do what they're asked. What voices and ways of speaking elicit some kind of rebellious response. Again, just figuring that kind of thing out could be very, very powerful. Again, if people don't, again, in the modern world, there's so much stuff going on in the modern world right now. So much stuff. If one gender gives another gender orders, and so again, like one of the things we think about with the whole identity and identifying who people are is you may actually come up with different speaking styles for different employees. How the computer talks to Susie may be different than how the computer talks to Bobby, which may be different than how the computer talks to Raj, right? Again, these are real things to be thinking about. Again, I only laugh because I realize the misery that this can create. Oh yeah. Oh, you don't know it. Oh my God! Until you actually start having real world arguments with employees, you're just like, what? But it's real. So anyways, something to think about. Okay, so now we're going to get to speech to text from mic, right? So when we start using the Azure Cognitive Services, one of the things you can do is you can do speech to text from the mic, and that is where we will go, and we will take a look at this first example that I was giving you folks. What is this one? This is HDMI 2. Again, I really need an HDMI switcher button here. So anyways, this is the code. So this is all on my MacBook Pro. So I have my MacBook Pro here, has a normal Mac OS installed onto it. Onto that, I installed the Azure the Speech Services. Basically, use pip install the Azure Services, and that's how I'm getting this to work. I then you go to Azure's platform. There, you select the speech services, you do the resource, that type of thing. It gives you a speech key. So this is basically like my security key to access speech services, which will be deleted by the time you're watching this video. And then you give it a region. The region is an important thing, especially when you're doing something like speech services, is remember, even in the computer world, the farther something has to go, the longer it will take for a round trip, basically latency, right? So I'm on the East Coast, so I'm in Asheville, North Carolina, so I just use East US as the region that I'm in, and they route me to the closest data center in the East US. If I was in Asia, I want to make sure the data center, that basically the region that I'm using is close to me. And again, the reason is if I'm talking to a computer, all of that has to be sent to the data center wherever it is, and it has to come back. Obviously, the closer that is the better. So we take a look at this. This is basically just a normal, pretty normal type of script here. Here, let me, there we go. So basically I got this from Microsoft. So Microsoft, this is under MIT license. I was able to grab it from their Git account, so I grabbed what they had and then I modified it a little bit. The first thing, this is Python. So in the Python world, you import the modules that you're going to use. So we import the Azure Cognitive Services Speech as Speech SDK. So this is how we will reference it going into the future. We then need a speech key and a service region. So that's my key, that's my service region. And then you need the configuration. Basically, you give it the key, you give it the region, and that basically does the security policy, make sure you can actually connect to the service, and make sure that you get billed properly. Speech recognizer, so this sets up the configurations and all that kind of stuff, the how the person will talk, that type of thing. I'm just using the generic. Then print, so this will print out on the screen down here, say something, so it just prints out, hey, I'm waiting for something to be said. Then we go down, I've created trigger words. So again, things to be thinking about with these kinds of systems. What do you want to trigger? How do you want it to be triggered? So I have a trigger word of hipster. If I say hipster, I'm going to be warned not to say that word anymore. And I have an exit word of close. So basically when I say close, that will close out this program. That's one thing to realize with Python. One of the issues with Python is continuous speech recognition is not naturally built into Python. You have to start the script and then you have to end the script. What I've done is, so basically they have a single instance, so it's recognized once. What I've done is I put a while true. So I took Microsoft's code. Basically with that, the while true isn't there. So you turn it on, you speak to it, it recognizes a speech once, and that's it. It cancels out of the program after that. So what I did was while true. So basically what this is doing is it's continuously looping. So I turn this on, and then it'll recognize speech, send it up to Azure. Recognize speech, send it up to Azure. Recognize speech, just put it up to Azure. But with that, you also have to remember to actually turn the Python script off. So that's one of the powerful things, again, with C#, some of the other coding languages. You don't kind of have to do this kind of duct taping together to make the continuous speech recognition work. You did here. So I have a warning. So if you say hipster, it'll say play nice everyone. This has gone on your permanent record. And when I say close, when I tell it I don't want to use it anymore, it'll say goodbye, thanks for playing. It'll actually speak that out. When you go here, again, while true, so it loops through all of this, and basically it's going to recognize, it's going to print out on the screen the text that was recognized. If there's a trigger word in the text string, it's going to say the warning. If the exit word is in the text screen, it's going to say goodbye, and it's going to quit the script. And then if nothing's detected, it shows some other stuff here. So if I increase the size of this, and I start talking, so this is what I was showing you before. So I can now talk to my computer, and it will write out what I'm saying on the screen. generally this is what I do. I can just sit here and I can talk to it. I can talk about all the things that I think about the world. So long as I don't talk about hipsters.
Play nice, everyone. This is going on your permanent record.
Now see, isn't that cool? It turned my voice to text, and then it was able to do a conditional on that text. I think that is really, really awesome. One of the things, though, with me showing you this, is that with Azure Speech Services, they actually try to do capitalization and punctuation properly. You can see so is capitalized, there's periods, the next sentence you is capitalized, or y is capitalized, the whole 9 yards. One of the things you'll realize if you go up here and you look at the trigger word, is lowercase, it's lowercase H-I-P-S-T-E-R, right? So if I start a sentence, hold on a second. Hipsters piss me off. Look at this. So since it began the sentence, it has an uppercase H, which does not match a lowercase h. Therefore, the conditional wasn't triggered. I am pissed off by hipsters.
Play nice, everyone.
Right?
This is going on your permanent record.
Because it's in a place in the sentence where the first letter isn't capitalized, then it actually gets triggered. And so this is, again, it's one of those stupid, anybody that's been doing programming for any amount of time, we gotta transform the text. But it is something to be thinking about. Again, when you think about like the trigger words or whatever else, should things be capitalized, should they not be capitalized, how are you transforming text, the whole 9 yards. The other thing that you'll realize here is how I did this particular string, is that as long as this word is within the larger word that I'm saying, this will trigger, right? So whether I say this singular, or I say that hipsters suck.
Play nice, everyone. This is going on your permanent record.
Right? Even that has an S on the end, the singular is within that, and so that it triggered. So again, one of the things you have to be thinking about with things like trigger words and how you do these conditionals, if you have a short word that happens to be a component of many other larger words, your system may be triggering all the time. So just something to think about. Hey computer, close.
Goodbye. Thanks for playing.
Anyways, so that's a pretty simple script there, and that kind of shows you how the triggers work and all of that kind of stuff. Again, very, very cool, very exciting. Let's see here. So when you're doing the continuous speech recognition, at least when you're using Python, you have to add while true, so it continuously goes true. You need to trigger it on, and you need to trigger it off. Right? So if you were going to be creating some kind of autonomous system, you could trigger this in many ways. You could have somebody press a button. So again, when we talk about the IoT world, we talk about different sensors, different inputs. Somebody could press a button. Or when a motion sensor gets triggered, possibly this thing turns on. Or any number of ways you could trigger this Python script to turn on. And so that's one of the things you have to be thinking about is, okay, how is this going to be triggered to start? Again, you think about that with like the old science fiction shows or whatever, and that's what they would do. Many times they would press a button or they would tap something. And so think about it. That action can be read by a device to trigger a Python script to start. Hey computer, X, Y, or Z. That is the trigger to start the Python script. And then afterwards, you need the Python script to end somehow. So with this, I say close, and so I tell the computer to close, it closes a script. One of the things that you may do is you may simply have it go through, and if it's not given a command within 30 seconds, maybe it cancels out, something like that. But you do, remember with scripts, remember with programming, it'll do exactly what you tell it to do. If you don't tell it to stop, you're going to get one massive bill from Azure. As remember, you only get billed for utilization, and getting billed for utilization is great until you turn the damn thing on forever. Anyway, so you need to trigger it on and you need to trigger it off. But again, very cool thing. So as I showed you with the continuous speech with trigger, let's see, you just add if this is in there, so on and so forth. And do remember, capitalization is an issue. So the next thing that I'm going to show you is how you can actually control a Raspberry Pi with your voice. Oh, this gets complicated. I've got an Arduino over here, I've got a Raspberry Pi. You can't put Azure Cognitive Services on either of these devices. We're gonna see how well this basically works here. So, what is going on with this particular system? So what I want to show is how you can have a real-time update. So a real-time update from something like an Arduino, how those real-time values can be read from the computer. So what happens here is this is an Arduino Uno with Wi-Fi. I have an analog temperature sensor connected to it. And so what this does is it's constantly, like every 3 seconds, it's sending information via post to my Raspberry Pi. So my Raspberry Pi has a full LAMP server on it, so Linux, Apache, well it doesn't have MySQL, has Linux, Apache, and PHP. So what happens is this sends a post to here, to a particular script on the Raspberry Pi. The Raspberry Pi, using a PHP script, grabs the value from that post and then saves it to a file. Then what happens is when I call to ask for something like a value, my MacBook Pro is able to read the value on the Raspberry Pi, and then it's able to speak that out to me. The next thing I have is being able to turn on the fan. So when I turn on the fan, what happens is I communicate, I talk to the MacBook Pro. The MacBook Pro says that telling it to turn on the fan. It then uses something called get. It basically sends a command to another script, a PHP script, on the Raspberry Pi. The Raspberry Pi then basically saves that value into a file, and then I have another Python script constantly running, and then it turns the fan on or off based off of what I say. So does any of that make sense? I was telling this to the people last night with Silicon Dojo. Like, this is the perfect example of why I want the full version of Silicon Dojo to exist. So the full version of Silicon Dojo, at the end of the day, I want it to be a hands-on experience. I want to do like 1 or 2 seminars per week, and then the rest of the 40 hours per week be able to have people come in and just be able to play and do things on their own. Because one of the problems you get to in the technology world, especially if you don't understand this stuff to begin with, is I start talking about PHP and Arduino, and it gets so confusing so quickly. It gets confusing to even explain. And so that's what I really hope with Silicon Dojo, is I'll be able to do a class like this and then be able to bring in people after the class, and they can come in and start playing with these things, and then they can start seeing how all the different things come together and actually create a system. Okay, so let's go here. Let's clear that. Alright, so let's just take a look at this a little bit. Again, so this is a lot of what we saw before. So I have different trigger words, so fan on, fan off. What is the temperature? I have responses. The fan has been turned on, the fan is now off. Goodbye, thanks for playing. And then if here, what I'm using is something called request to get. And so using the, it actually uses get. So it uses get, and it sends the value of command as on, or sends the value of command as off to the PHP script on the Raspberry Pi, and that's how I'm sending the command. So if I say fan on, then that will trigger this, that sends command, the value of the variable command as on to this, it processes it. If I start to say the command off, it processes it, and with this, so alert equals, so it's going to go to this web page, currenttemp.html. So every time the Arduino sends a value to the script here, it writes the currenttemp.html, and then basically it's going to simply read whatever that has to say. Oops. The battery ran out. Hold on. Oh, you're killing me here. Okay, that's not battery. Alright, let's see. That's the thing. When you're doing like live demos, when you're doing live demos and you've got Arduinos and Raspberry Pis and different power devices, one of the important things I want you to realize about this is entirely self-enclosed. Look, this is not connected to a computer at all. This is connected to a USB battery pack, to the Arduino, to the sensor, and then it's sending all the information wirelessly. I want to show you this. So again, you could have multiple of these sensors all around your environment, and then you could query your computer about different things, like what is the temperature in the living room, or what is the temperature in the kitchen, what is the temperature in different different areas, right? You can ask that kind of thing. And what's really cool is, like I say, these are all entirely independent. Okay, so let's hope this works properly. Okay. Hey computer, turn the fan on.
The fan has been turned on.
Right? So it sends that variable value for command as on. That gets parsed by the Raspberry Pi. That gets saved into a file, and then that gets read by the Python script. Hey computer, turn the fan off.
The fan is now off.
And now it gets turned off. Right? So now I am communicating, it's turning my words into text, and then based off of what is in that text, is then sending a command to an entirely different device. Hey computer, what is the temperature?
471.98.
Okay, so here's a problem. So when I was creating this project, I burned out my sensor. So these analog temperature sensors are really nice, only they're very fragile. And I did something stupid and I burned out my last analog temperature sensor. So what I wanted to show you here though is that this is a dynamic value. So don't worry about the temperature. It's obviously not 471 degrees in here. But if I put my finger on the sensor and I wait a second or two, I'd say, hey computer, what is the temperature?
471.98.
Oh, I hate live demonstrations. Hey computer, what is the temperature?
471.98.
Okay. Hey computer, what is the temperature?
471.98.
Yeah, okay. I was doing so well. I was doing so well with this class. Okay. Would you believe that it's just staying the same temperature? Anyways, that thing is supposed to be sending the values there, and it's supposed to be changing. During the live demonstration, I'm not really sure what's going on. Hey computer, what is the temperature?
471.98.
Anyways, if you want to see just a little bit of what's going on, again, if we go down to the Raspberry Pi. Oh. Okay, so I have a Visual Code actually installed on the Raspberry Pi. Again, Visual Code is the easiest way to do most of these different programming languages. So what do I have here? So, so this is where when I send the command, so on that other page, when I was doing 10.0.1.8 /IoT.php, and then I did command equals on or command equals off, this is that script. So basically it gets the value from get for command. It then assigns that value to $command. And then what it does is echo file put contents. It then writes that command into the command.html. Oh, maybe that's the problem. Uh-oh. Maybe that's the problem. Oh, no, never mind. That's in the command.html. I'm getting confused. Oh, it's hard. It's hard doing this stuff. Anyways, I'm getting confused what I'm talking about. Anyway, so this is put in the command HTML, and then what happens is fan control then reads from command HTML. And so basically what this is here is this is what's required to actually turn a GPIO pin on or off for the Raspberry Pi. So fan is basically on pin 17. What this does is response. It looks to 127.0.0.1. That's a loopback address. So that's if you put 127.0.0.1, it'll go to the web server that's on itself, and it looks for the command.html. Command basically is the text that's in command.html. If the command is on, fan will get turned on. If the command is off, the fan will get turned off. Else, the fan will do like a little turns on for a second, then turns off, and then it sleeps for 1 second just to make sure nothing gets screwed up there. And so this is the Python script that's continuously running to make sure this thing actually turns on or off appropriately. And then what we have is the Arduino PHP script. And again, this is the same thing. So the Arduino is sending a post to Arduino.php on this particular server. It sends a value for the temp variable, that's assigned to the temp variable, and then echo file put contents, that gets overwritten onto the current temp.html file, and that's supposed to be how it works. I don't really understand what's going on right now because it's a live demonstration, and so if things don't break during a live demonstration, you know, you're not doing it properly. The other final thing, again with the Arduino, is this is the Arduino code here, just to kind of give you an idea of what this looks like. So this is an entirely different programming language. This uses the Arduino IDE. So you write this, and then you upload it to the Arduino. And basically here, this is where you actually connect it to the Wi-Fi network. Here is where you get the value for the temperature sensor. So the analog temperature sensor basically gives a voltage. You multiply, divide, do a whole bunch of different things with that voltage, and that's supposed to give you the temperature values. And then down here, this is where you can actually send post values to the script, and it's supposed to work properly. I don't know why it's not working properly right now, but it's not, because that's how things go. Anyways, so I hope that makes a decent amount of sense. And so that's how a system like this works. And again, that's one of the things to be thinking about when you're going to be building out these kind of IoT infrastructures, is how is the communication going to occur? And if something doesn't work the way that you want it to, how can you design similar results? Again, because my plan was that essentially I was going to build everything right into the Raspberry Pi. The Raspberry Pi was going to have the speech recognition built into it. I was going to have a speaker. I was going to have a microphone on the Raspberry Pi. I was going to connect the temperature sensor to the Raspberry Pi. This was actually going to be its own, own thing. But the speech SDK doesn't work on the Raspberry Pi. There's a couple of other things. And so in order to get the same results, I had to figure out different ways for having things communicate and different ways for being able to trigger things using the Raspberry Pi and these other computers. So again, that's one of the important things to understand in the technology world. Like, a lot of people think that the technology world is complicated, or individual technology is complicated. The important thing to understand is most technology is actually not that complicated. Any one core component of technology you can be taught in about 40 hours. In about 1 week, I can teach you most any subject area. A+, I can teach you in 1 week. Net+, I can teach you in 1 week. Python, I can teach you in 1 week. PHP, I can teach you in 1 week. Arduino, I can teach you in 1 week. Right? Or less, with some of this stuff less. The thing is, the individual concepts aren't what's complicated. That's the easy bit, right? Networking is not complicated. Programming is not that complicated, actually. Where it gets complicated is the networking and the devices and the different processors and the different programming language and the different sensors and the different SDKs and APIs and all that. Taking all of that and turning that into a system with a 99.9% uptime. That's what we get paid for. So, just one of those things to think about when you're looking at this. Oops, and let me turn off that particular script. Again, I left that script running, and so it kept running. Okay, so then past that, let's go back here. So basically what this slide shows is how I turn the fan on or off, basically diagrams that out. So I speak to the computer. The computer sends the speech to Azure Server. Azure Services sends the text back in what's called a JSON format. Then basically Python parses that JSON format. If conditionals are true, then it sends a command to the Raspberry Pi, basically to the IP address of the Raspberry Pi with the variable name and the variable value. That gets sent as a GET. PHP grabs that value as a GET, saves that to a file. There's a Python script that's continuously running. That Python script is continuously looking at for the command in that file, and then it turns the GPIO pin either on or off based off of the value in that file. So that's essentially how that works. We can also do, when we're doing speech, we can also do speech to text from file, which is actually pretty cool. So basically, again, when we start talking about being able to have the computer dynamically speak, it is very easy to dynamically create text, and then this will speak that dynamically created text. So we go here. Right. So this is the script that I created to be able to read from a text file. So again, another pretty short script here, about 38 lines of code, even with all the commenting. The big one here is you open, so I'm going to open the file speech.txt as read, as file, and then it's actually going to then read the file out. One of the things it's also going to do is it's going to save what is read to a WAV file. Now, why this is important, again, when you start thinking about how systems are going to be interacting with each other, possibly the systems that you're using will not be able to have a voice built into it. So if you can output a WAV file, and then you kind of have a system that is able to play a WAV file and simply play the WAV file, then you essentially get the same results. So imagine if I have some kind of dashboard, a web browser-based dashboard. And so the web browser may not be able to speak to me using the Microsoft SDK, but I could have the server basically speak whatever I wanted to say, save that as a WAV file, and then that WAV file could then be played on the web page. Right, again, thinking about how all this is done. So we do the run, we do this.
This is being read from a file. So that means that you can create an entire UX around audio output. So isn't this really cool?
Right, so basically this file here, what's getting read, comes from speech.txt. So it's just a simple text file that's saved on my computer, and so I can put, anything that I want in here, right? So I can do this, and then I can say, hey, look, this computer is talking. Isn't this really cool? And then I can do file, and then I can do save. And then I go back to the same script that I was doing. I do run, I click on it.
Hey, look, this computer is talking. Isn't this really cool?
Right? So think about that. How easy is it to create dynamic text? And so now having your computer speak dynamically is as easy as creating dynamic text. So that's one of the things that makes this really cool. The final thing here is, then I'll just show you, is you can actually then do a WAV to a text file. So you can have a WAV. So think about, let's say in the YouTube world, right? The YouTube world, we create videos, and then what if we want to know what's said in a video? So what we could do is we could strip out the audio as a WAV file, and then we could have Azure literally be able to read that audio file and spit out the text. This is one of the things that's been being used right now for a lot of services such as YouTube. One of the reasons people are getting screwed on YouTube right now is because I think that they're using more and more of these speech type services to moderate content, right? So a lot of YouTubers, right, we have been under the same rules for 5 or 10 years, right? For a long time, we've been under the same rules. The thing is, YouTube hasn't cared about those rules. So whether you swore, whether you said naughty things, it didn't really matter because YouTube did not have the ability to actually go through and be able to parse what you were saying, right? That was the whole thing, right? As long as you don't swear within the first 30 seconds of a video, you were okay. You were okay because they only had the processing capability of dealing with the first 30 seconds of videos. What's interesting now is with these kinds of services, it's very easy to turn audio into text, and then as soon as you turn it into text, it's very easy to parse that to see what's in there, and that's why I think we're getting more and more moderation flags going into the future. And so that's one of the things you can do. Let's see here. So if I clear this out, basically what I have here, right? Yeah, so let's see here. So the normal cognitive services thing. So with this, I have a file name of test.wav. So for this particular script, it's going to open the test.wav file. It's then going to output to write to text underscore output.txt, and so on and so forth. So if I run this, and then I actually click on it, it is now going to show you what it's recognizing. So this is kind of like a weird WAV file. It's a WAV file that's actually used for training systems to learn what people are talking about. So basically what it says here is it's going through and it's saying, a large size in stockings is hard to sell. It's showing what it's trying to recognize. It shows you what it finally did recognize, and then it outputs this to that output.txt file. So if we minimize this, what's the text output? Yeah, and so here, I don't know if you can see it. So basically, it listened to the WAV file. It then, instead of speaking or whatever, what it did is it simply wrote that into this text file. And now that it's in this text file, you can parse it or you can screw around with it all of you want. So again, this is another interesting thing to be thinking about with how you can use these types of speech services. Boisies. Okay, so we did speech to text from file, we did text to speech to wave. Okay, the final thing to be talking about is the price. Again, the price on all these services is absolutely amazing. So Azure has a free tier, just like everybody has a free tier anymore. So for speech to text, 5 audio hours are free per month. Now for speech to text, realize that's not 5 hours of the script being on, that's 5 hours of speech being detected. So think about this. You put this in something like an office environment, and people are literally not talking all the time. They're just tapping away, doing whatever. And so you're only going to be charged, or it's only going to go against your limit based off of how many words are actually detected. Though one of the things to think about in the real world is what happens if somebody turns a radio on. Again, somebody think about how these computer systems operate, right? If you put one of these systems into a normal office space and everybody's quiet and they're tippy-tapping or they have headphones on, then it's probably not going to detect very much speech. If, on the other hand, somebody comes in with a radio and turns that radio on all day, well, what does radio do? Radio is speaking all day. It's kind of like a YouTuber. It speaks all the time. That's what it gets paid for. And so all of a sudden you may blow through your limits simply, because of the environment. Things to be thinking about there. Text to speech, for free you get 5 million characters free per month. So actually, reading the text file into speech, 5 million characters. I have no idea how many words that averages out to, but it seems like that's a metric crap ton of words. That's all for free. Speech translation, you get 5 hours for free per month. And speaker recognition, again, that's not something I showed you today, but you get 10,000 transactions, recognitions per month. It's a hell of a thing. Again, when you actually do go and you take a look at the pricing, again, this pricing is amazeballs. It's what we call in the technical world amazeballs. Again, as somebody, remember, when I started doing videos back in 2009, I had to build and rack my own servers. Everyman IT, the first iteration of this video thing that I've been doing now for 12 years, was called Everyman IT. In order to make that happen originally, I had to rent space in a co-location facility. I had to build my own Xeon. I had 2 Xeon servers. There was so much. I mean, it cost like 10 grand just to get a crappy little project up and running. Now, look at this. On actual pricing, speech to text standard is $1 per audio hour. So you can have one of these devices just listening or whatever else, trigger and listen, and you are only going to pay $1 per hour that there's actual amount of speech there. That's a hell of a thing. Text to speech standard is $4 per 1 million characters. Again, I have no idea how many characters an average word is, but you figure if, I don't know, the average word is 4 characters with A's and thes and was and all that kind of stuff. I mean, it's like $4 for 200,000 words said, which is ridiculous. Again, speech translation, when you think about that, $2.50 per audio hour. So imagine putting this into an environment like a hospitality environment and something like that. You're paying $2.50 per hour for translation services. That's absolutely insane. And then speech recognition, when you're actually doing it in the real world, again, we didn't show that today, but $5 per 1,000 transactions. So 1,000 times the computer system verifies whoever is talking is who they're supposed to be. You pay $5. Again, in the technical world, that is peanuts. That's what we call it. Yay! That's cheap. So cheap. So cheap. That's like for IT people, we get excited about this the way normal people get excited about going into a Best Buy on Black Friday, Stampede. What? We only have to pay $1 per audio hour? Give me all the hours you got. It's amazing. So anyways, that's the basic presentation here for Azure, cognitive services, speech services. I think it's great. I think it's amazing. It's really cool. Again, what I am able to do with Python, what I'm able to do relatively easy or relatively inexpensively it just blows your mind. And then when you start connecting all of these things together, that's when it becomes just mind blowing. Because again, like just having a computer speak to you and give you little bits of information, yeah, whatever. But remember, everything that I'm writing here is in Python, right? So all the APIs that you get in Python, you can now communicate with voice. I think about this from a security standpoint. Imagine, you create your own security system for your house, and now not only can you connect to things like lights, not only can you connect to things like alarms, but you can also connect to Twilio, right? You can have scripts to send off Twilio messages, right? So if I hear my house being broken into, I can say, "Hey computer, I'm having an emergency." It can turn on all the lights in the house. It can turn an alarm on for the house. It can then start sending, again, through Twilio's API, it could then start sending SMS messages to your friends or family with voice services. So Twilio has voice services, so basically you can send a call, right? Essentially like with a WAV file. So you could actually have Twilio then call 911 and say, this house is being broken into, please send the police. All of that can be triggered now because you can speak to your computer. Your computer turns what you're speaking into it in text. It parses that text, and now it's just a conditional. Just like in the past, where you might send data to a database, you might print something out on a printer, you might do a whole bunch of different things. Now instead of sending information to a printer, you're sending out a Twilio SMS. Now, instead of getting input from the keyboard or whatever, people are actually able to speak to it. I just think that get amazeballs. It's amazeballs. So anyways, that's the basic class. If you don't understand everything going on here, again, there's a lot of different things, the Arduino, the Raspberry Pi, everything else. I'm just trying to give you an idea of how all of this can be used in these larger type systems. And again, you start thinking about how you could scale this up. Imagine at an event. I think about that with like with a lot of large scale events nowadays, music festivals, that type of thing. How do you try to keep your people or your attendees healthy? As I've talked about a lot with climate change, in a very small area, the temperature can go up or down by 20 degrees. So let's say it's a hot day, you put out a lot of these temperature sensors all over your environment for something like a music festival, and then imagine simply if the temperature gets up to, let's say, 105 degrees in one area and it's 90 degrees in a different area, you could use these speech services to trigger a message to say, "Hey everybody in this one area, hey everybody in this area, it is now reading 105 degrees. Can we recommend that you go buy a refreshment and go to this other area where it is 15 degrees cooler?" Right? You can do that kind of like with all of these different sensors and devices. You can start kind of doing that thing and then being able to communicate with people in a way that they understand. Again, in the modern world, when we think about disabilities, right? Not everybody can see, right? So if you have a music festival, you may have some blind people that go to a music festival because it's a music festival. Right? You don't gotta see to listen to music. You don't gotta see to smoke a little ganja. You can smoke some ganja and listen to some really nice music and be blind as a bat, right? Well, think about that. If you have some kind of alert system that's flashing lights or whatever else, or you have a big billboard, billboards are worthless to blind people, right? So if you can create a system where now you can actually speak, now the people that can hear, basically the people that can see and hear, and the blind people, they can now understand what's going on. These are some of the things to be thinking about. Another thing that I think about is kind of interesting in this modern world is, again, however you feel about politics, not going into the whole politic thing right now, but there is this really emphasis on culture in workplaces and basically toxic culture in workplaces. One of the things a lot of people don't realize is, from an employer standpoint, is that as far as regulations and laws go, employers are legally responsible or legally required to provide employees a safe work environment. Right? This is actually a legal requirement. If they don't do it, they can get sued. One of the interesting things, again, when we start talking about words, we start talking about toxic culture, however you feel about this kind of stuff, this is a real liability concern. Now, in the past, what is a boss going to do? If a boss has 100 employees, a boss cannot be everywhere listening to the employees all the time, making sure they're not saying things that are asinine stupid, right? It's just an impossibility. Everybody understands that. The legal system understands that, the whole 9 yards, right? So if you have a toxic person, a racist person, a sexist person, whatever else, saying all kinds of garbage, if it does not come to the attention of the boss, which many times it doesn't, right? Whatever. What's kind of interesting about this, again, when we start talking about like surveillance societies and surveillance technology, is imagine if you have these audio capture devices in different areas in your building, and it's simply processing the information, not to spy. It doesn't care what happened to your kids. It doesn't care about your medical condition. It doesn't care about other things. It's just making sure you don't say the N-word. Just making sure you don't say very specific things. They're very, right, should not be said in a business environment. And then if those things are said, right, that can be captured by one of these systems. It can be logged. So where it was said can be logged. The timestamp can be logged. It can log what was said before. It can log what was said after. And then that can be sent to the boss, and the boss will then be responsible for doing decent management. Again, one of the things to understand, whenever I talk about using these systems for management, I am not saying that we should offload management functionality to the computers. Humans need to be managers. When you offload management to AI, you get what's currently going on with YouTube, where people like me get 3 punishments for not breaking the rules, because the AI is kind of stupid. The point is not to have the AI or the computer or whatever else actually do the management functionality. What these devices should be doing is they should be giving the managers more insight into their environment so that they can stop problems before they become a bigger issue, right? The first time somebody says something stupid in the work environment, just having them come into the office and say, hey, look, the computer flagged that you said X, Y, or Z. Look, in our environment, those types of things just should not be talked about. Please leave it out of our work environment, right? Simply being able to have that simple management conversation, maybe they'll solve a lot of problems in the future, right? If you have a new person come in and they say something stupid, that gets flagged rather quickly to management. They can get smacked on the hand and it can go how it goes. One of the big problems we have with companies nowadays is somebody comes in as an intern or whatever, they start saying something stupid, and then they get hired normally and they say something stupid, and then they become like junior level whatevers and they're saying stupid things, and then by the time they're senior level people, well, they've been saying this stupid garbage for the past 5 years, and how dare you take away my right to, right? It gets into, right? The quicker you can deal with problems, the better it will be from a management perspective. One of the other things to be thinking about too is with these kinds of systems, when you're thinking about management, is simply by alerting people that it's been recognized that they're saying things that may not want to be said in a corporate environment, that may keep them from saying things. I think about this, again, I have a criminal justice degree, again, bias warning, I have a criminal justice degree, I am not anti-police, to be clear. And so one of the things with police and all that is whenever you talk about the continuum of force, many times people only talk about the final 2 parts of the continuum of force. So, right, there's a lethal force and then a less than lethal force. It's not non-deadly force. There's almost no non-deadly force. As soon as you smack somebody, it may all go to hell. Anyways, so whenever we talk about police officers, we talk about lethal force and less than lethal force. Those are the 3rd and 4th steps on the force continuum. What people rarely talk about is the first 2 steps on the force continuum that are considered force in the security policing world. The first is presence, and the second is simply, hey you, what are you doing? Communicating that you see that somebody's doing something that looks suspicious, right? And so you think about it in neighborhoods, simply by putting a police officer on the block of a neighborhood, maybe many times that will solve many crime problems, and having the police officer actually be awake and have a cup of coffee and go and see what people are doing, that can tamp down with crime in the area, that can tamp down with social issues. One of the things to be thinking about with these kinds of systems is, again, what if you just have an alert system? It doesn't even go to the boss. It doesn't even go to the boss, right? What if a red light goes off? What if whenever you say the N-word, or I don't know, your comments about the Holocaust, again, to be clear, I just want to be crystal clear for anybody out there, like, I would never work for you, Eli. I never want my employees talking about the Holocaust on Silicon Dojo time. I don't care what your opinion about the Holocaust is. Don't talk about it. Red light, Eli's talking about Holocaust. Doesn't need to be said. Anyways, right? Because I know I get a lot of snarky people like, oh, you seem like a horrible boss. What about freedom of speech? It's like, no. If you're talking about Holocaust and the company time, there better be a damn valid reason for that. Anyways, but just imagine any of these trigger words. And all that happens is your red light goes off. And people say, probably shouldn't be talking about that. Again, that is people. Again, one of the horrible concepts in the modern world, that's people self-censoring. Is it appropriate in this environment to be talking about this particular subject? Again, whether it's our current president or the previous president. Again, when I talk about flagging words, again, so many people are, oh my God, the whole politics thing at this point has just gotten insane. To be clear, everybody's insane. Both sides are insane. But again, you think about this within a business environment. Is there a reason for folks, to be talking about this political stuff? Again, especially when a lot of people get pissed off and irritated, any side, everybody hates each other about it. Again, just having a little sensor that goes off, hey, don't talk about Truman. Uh-oh, my employees are talking about Eisenhower again. We can't have that. Red light, Eisenhower. Red light, Eisenhower. Right? Anyways, again, these are really some things to be thinking about. And again, like beyond punishment, beyond having the technology actually do that management functionality, having the technology, be able to give prods, be able to give insight into the environment, the whole 9 yards. Again, as a manager, as a boss, one of the biggest problems that you have is you just have very little insight into your environment. Again, especially as your company grows bigger and bigger and bigger. I know it sounds like a horrible excuse. I know it sounds like passing the buck, but the reality is it becomes ever more difficult for employers, for bosses to really go on with, understand what's going on with their environment. They know their metrics, they know their sales, they know their profit loss, they know their marketing costs. Anything that they can track, they do try to track to make sure everything's going properly. But there's a lot of this stuff that simply falls through the crack, not necessarily because they want it to, but we don't have, you can't track things that there are no systems to track. And so these types of cognitive services allow management and bosses and that type of thing to have a much better overview of what's going on in their environment. And then again, like I say, being able to control the environment. So being able to open doors. Hey, computer, open this door. Or hey, again, when we start talking about the stack, when you're able to communicate with your Active Directory infrastructure through voice. Think about the power of that. Right? Just absolutely amazing. So anyways, that was the class for this particular week. We didn't have a lot of problems, except for today. The temperature sensor kind of worked yesterday. It was giving bad readings, but at least it dynamically worked yesterday. One of the things that I will say, again, if you're going to do a presentation like this, the simpler you can make the demonstrations, the better, because just like in the real world, technology breaks. Technology doesn't care whether it's in a production environment or whether it's in a class. It'll just start doing stupid things because it wants to. So, do think about that with, what kind of demonstrations do you really want to do? Again, and also think about how complicated you want to make things. Like I say, for myself, I was willing to spend a day trying to troubleshoot this Raspberry Pi to make it work, because since this education thing is what I'm doing, most of the time, it teaches me things, so I know not to run into those problems in the future. One of the issues for you, though, if you have a full-time job and you're doing a Silicon Dojo, you're doing the seminars as a side gig, if this is a side gig and all of a sudden troubleshooting takes up a couple of days of your time, that can be a little bit dispiriting. So I think that is one thing to be thinking about if you do a seminar like this, is think about how complicated do you want to make all the examples that you're showing. That's one caution. The other caution too is there are so many things going on with these demonstrations, right? We have an Arduino with Arduino Code, with Raspberry Pi, with a LAMP stack with PHP, we have Python, we have the Azure SDK. One of the issues is if you have newer people that come to your presentation for a class like this, is that you may have to dumb down some of the stuff. I had somebody in the class last night that didn't know any programming languages, and so all of this code, we had to spend about 20 minutes at the end, and I actually walked through all of the code to try to explain what was occurring, and so that might be an issue that you run into. Again, so depending on the level of the students that you're going to be interacting with, you may want to dumb this down significantly, or like simply do the class showing those initial verbal triggers where people say hit hipster, or you say close, just show that and don't go any further. That's something that you may want to think about. Again, as always, these classes are open source or whatever. My goal here is to provide education for basically anybody who wants it. Again, I believe in authorityless, gatekeeperless education. I do not believe that we should be able to keep people from being educated simply because we don't like something about them. I think that's horrifying. So this class, use it as you see fit. Copy it as you see fit, modify and edit it, and present it to whoever you want as you see fit. The class notes, the code, all of this stuff is going to be on silicondojo.com. So if you go to silicondojo.com, down in the description section, all that code and stuff will be there. I am planning to actually get a GitHub account. I haven't really needed GitHub until this point, so I haven't really cared. But as I start doing more of these projects, GitHub is a hell of a lot easier way to distribute code than Silicon Dojo is. So I will start putting some of this stuff on GitHub, but I don't know if this particular set of classes will be there, right? So that's just something to think about too. And do remember, Silicon Dojo is free to the end user education. So the people that were in class last night, they did not have to pay to be in class. You obviously are not having to pay to watch, to learn from this class, but we do have to get paid. Free to the end user is not in fact free. We do got to get money from somewhere. So if you can go to our donor box link, or whenever you're watching this, whatever other donation system that we have at the time, and throw in a couple of dollars, hopefully monthly. If we do recurring revenue, that's always lovely. Again, right? Pay what you can. Everybody has this idea. Well, if everybody paid what we can, it would be a much better system. Yeah, but what if everybody pays nothing? But nobody ever seems to ask that question. What if everybody decides that they're going to pay nothing? Stuff costs money. So, anyways, so if you want to help, support this whole thing that I'm doing, again, click on the donor blocks or the donation link and go there. And with that, as always, I enjoyed teaching this class. I look forward to seeing you at the next one, and hopefully sometime here in Asheville, North Carolina.